So now we are going to find the center of gravity of the entire shape. And the equation we're going to use is the sum of the area multiplied by x bar, y bar, which is the location of the center of gravity that we're looking for, equals the sum of the individual areas multiplied by their distance, the distance of their center of gravity from the reference point. So in order to conduct this successfully, we're going to use a reference point. You can pick any point on your body to be the reference point. I'm going to pick this corner here. If I pick this corner, for example, or here, I'd get a different answer for x bar, y bar, but it will be the same location on the body. Now, let's start by finding the total area, sum of A. So the total area is going to be the area of the curve, which was 16.6, plus the area of the rectangle, which was 50, minus the area of the circle, which was pi, because the circle is a hole, so we subtract it to find the area, plus the area of the triangle, which was 20, multiplied by x bar, y bar, equals. Now, each shape, the area of each shape multiplied by the distance of the center of mass of that shape from the axis. So starting with the first one, the area of the curve is 16.6. Let's draw the location of the center of gravity on our body. If you recall, center of gravity was around here somewhere. And the x bar, which was the distance to here, was 1.875. The y bar was 2. Now, we have to be a bit careful here. We're measuring everything to this reference point. Everything has to go back to this axis when we use this equation. So we need the center of gravity of our curve to the reference, which is this distance here. But we have this distance. So to find this distance, we have the total distance minus this one gives you the remainder. 5 minus 1.875 is equal to 3.125. So that's going to be 3.125. Now the y bar to our axis is 2. We don't have to subtract or add anything. It's already to the axis, so it's going to be 2. Plus 50, that's the area of the rectangle, multiplied by the center of gravity of the rectangle from the axis. The center of the rectangle is here. It's in the middle of the 10. So that distance there is going to be 5. 5 plus 5 equals 10. This whole distance here is 10 to the axis. Always go back to the axis. 10. Now, the y is going to be half of 5, just like we found previously. That's 5. That's going to be 2.5. Minus the area of the circle is pi, multiplied by the distance of its center to the axis. The center of the circle is here, the axis is there. This is 5. Now we know this is going to be 1, the radius. We need this distance here. To find this distance, we have 10. This whole thing is 10. This is 7. 7 plus 1 radius is 8, plus another radius of 9, and then plus that distance reaches 10. So that distance there must be 1. So 5 add 1 is 7. The distance of this to this line is 7 centimeters. 7. Now the height is going to be, if we take a look at the center of gravity, the radius is 1 plus 2 is going to be 3. Finally, plus the center of gravity of the triangle to the axis. Now the triangle center of gravity, as you can see from last time, was 8/3. But again, we have to go all the way back to the axis. Always go back to your x and y axis. This is 10, this is 5, so all that is 15 plus 8/3. 15 plus 8 over 3 is 17.6. Don't forget to multiply by the area first, area, then multiply by 17.6. And then similarly here, except here we don't have to add or subtract anything. You can see it's already on the axis, the x-axis. So y bar is 5 over 3, which is equal to 1.6. 1.6 in decimal figures. Now, let's continue with the equation. First of all, let's find the total area here. The total area is 83.45. X bar, y bar equals, with these vectors, all we do is multiply the vector by the number. So this number here times x, this number here times y, x, y. So 16.6 times 3.125 is 51.875. 875. 16.6 times 2 is 33.2. Plus 50 times 10 is 500. 50 times 2.5 is 125. Minus pi times 7 is 7 pi. 3 times pi is 3 pi. Plus 20 times 17.6 is 352. 20 times 1.6 is 32. Now you add all these vectors together. Don't forget there's one of them is minus. So add all the x's, add all the y's. That should give you a grand total of 881.88. And the y will be 180.77. That's the total vector. Here we have x bar, y bar, and we still have the total area here, 83.45. Now divide the x by the total area, that'll give you x bar. Divide the y by the total area, that'll give you y bar. So in the end, we should have values of x bar, y bar vector is equal to, the x should be 10.56 centimeters and the y should be 2.16 centimeters. So you can see it's quite realistic because 10.56 is around here and you got 2.16 is around there. So it's around the center of the shape. We have a hole here, so it's going to shift to the right a little bit, and that's what's happened in our component.